Good morning, everybody. I hope you had a good evening last night, whatever you did. Now, we went on a journey yesterday with our Visual Studio from Workbench. And this isn't exactly going to be a journey today, but we'll give it a go. So today we're going to talk about Synergy Database Management System, or SDBMS as we know it. It's going to be an SDBMS refresher looking at some of the new features and capabilities within SDBMS. But hey, come on, let's be honest here. We're going to talk about ISAM, index files, and that's about it really, the best bits about them. At the end of the day, Synergy ISAM files, they rule our worlds. It's as simple as that. Our applications have needed data and to store data from the beginning of time. Many of us have got data that goes back years, decades, or even into the last century. Many systems started out as single-user systems working on local machines talking to local data. Our server-based systems with multiple people all accessing the same data, again, on the same machine, things like VMS, Unix, etc. The file system had to become clever. It had to become a lot more than a simple filing system. For example, you could not have multiple people updating the same record at the same time because changes would get lost and things would be rather confusing. So Synergy files incorporate a powerful locking system, which can also cause problems with deadlocks, etc., but you've got code that handles that. The capabilities of an ISAM file today has continued to keep up with the demands of, well, you lot in the room, really. ISAM files now provide terabyte support, meaning you can fit totally crazy number of records in a single file. At the same time, we've implemented features that now allow you to limit what you can actually put in the file, but we'll talk more about that a little bit later on. The simple primary key concept allows you to define a single entry point into each record that your application can use to find the required record. In the days gone by, users would normally be expected to know this sometimes cryptic code, and the scary thing is most people actually did. I still remember to this day the code 03501 is a 6-paneled, white, textured, grained internal door. I don't really want to know things like that anymore. Keep me awake at night. There's no real need for or reason for more than 8 keys, but hey, ISAM needed to grow and with the times, and the ability to add a 9th key was introduced. I remember the email when it came from Scott. There was total outrage on the listserv. Only 9 keys? Is someone having a laugh? Well, actually, yes, it was April the 1st at the time. We extended the ability to define 255 keys. And most of those keys can be made up of different segments, of different Synergy data types, and we'll talk about that a little bit later on. As the infrastructure improved, networks got faster and people wanted to run their applications on different platforms and different environments, so we introduced XF Server. And I'll probably guarantee everybody in this room uses XF Server. XF Server provided you the ability to access the same data, but now across a TCP/IP-based network. The clients talking to XF Server could run totally different operating systems from both a server where the data resides and the other clients accessing data. Server operating systems such as OpenVMS, which we know does not even run Synergy DBMS database, it's running RMS, but because it's quite similar, we're able to take full advantage of it. Unix can be both a server hosting XF Server and a client talking to another XF Server machine. So you could actually daisy chain things across with a Unix machine. And of course, Microsoft Windows can be, like Unix, both server and client. The cool aspect of XF Server is that there's no changes required to your application. As long as you use logicals to open files, record locking and all the powerful capabilities built into Synergy ISAM were obviously all still in place. All quite impressive, and if you think this image actually shows the state of play back in the 1990s, maybe around some of these albums actually. So why the need for an SDBMS refresher? You're all using all that's great in ISAM files today, but then, well, maybe not. I'm going to cover a few of the newer features and talk about some real-world examples where we've worked with customers to utilize some of these features. Maybe this will be your light bulb moment, that I didn't know I could do that moment, or even just a cool idea moment that you can take back to the office and address an issue or a problem that you've been having. Or maybe just furnish a request that's been on your to-do list for a while. Let's look at a simple record area. There's nothing more simple than a transaction record. There's a transaction date, a reference, a number, a description. We also hold the sales account and the transaction value. Dead simple. And now we add the dreaded overlay. There are a few ways to do this using the @ symbol like I've done here. And you can also use record X. You can even create a group and include the individual key segment fields inside that group. All of these are valid ways to define or redefine the Synergy data. And I expect that many of you, if not all of you in the room, actually do this and have code like this. Yeah, you don't admit it. The overlay is a great way to access the whole key as a total, single entity, and it's totally valid. Keep doing it. I'm not saying don't do it. But don't define the actual keys as a single A26 alpha field, because it's not. These are the actual key segments. So when you create the file and define the keys, use the actual key segments. This helps the underlying system utilize the segments, like XFODBC, and the select class. This is still totally valid code. Your application will not need to change even though you properly define the keys segments in your file. Defining keys correctly in products like the repository help everything Synergy related. Using the individual segments allow you to correctly define all the segment types. And there are many segment types. Correctly defined key segments helps improve XFODBC access to your database. And correctly defined structures in the repository will greatly improve your CodeGen experience. Using CodeGen, Symfony Framework, all that good stuff, get it right in the repository and it'll be right everywhere else. But we all know about setting the right key segments, yes? But what types of key segments do we actually have in the current ISAM file that the modern developer can get at? Well, actually there's quite a few now. Obviously the most basic one is the Synergy alpha type. We all know what a Synergy alpha type is. The segment can contain basically any characters you want. Did you know, however, that you can now define the alpha segment as case insensitive, which obviously means that the case of the key is no longer matched. So you don't need to force everything in that key to be uppercase for your matching to work. Decimal key values hold values from a maximum negative to a maximum positive based on the size of the key segment. Did you know you can have implied decimal values? However, the number of digits to the right of the decimal value must be maintained by the application, which could give you strange results in non-language file access. So you might want to avoid. You can specify integer key values, the native Synergy integer types, I1, I2, I4, and I8. And obviously native unsigned integers can also be defined. It's not just a sequence of alpha bytes. And now some of the new key segment types. The sequence segment will be assigned a value when a record is created. The value will be one more than the value assigned to the last record that you created, and it starts at a value of 1. This is a cool segment type and ensures that you can always read records in the created order, regardless of any other key value or structure. It can also be used to ensure that you've got a unique key value. Add it as a segment into your primary key, for example. If a record is deleted, the sequence number is not reused and will never be assigned to another record. To define this type in your record area, you must use an I8 field. There's a new timestamp key segment. This segment type represents the current UTC time in microseconds. The value inserted into this segment is the current time by the process performing the modification to the record. So in an XF server environment, that will be the server, not the client. The segment time in your record area must again be defined as an I8 field. Similar to the timestamp segment, there is the C timestamp segment, and this is populated once when the record is stored in the file, and it will never change. So it's now easy to find all records that were created on a certain date, or to see all records that have been changed since they're being created, because there's a difference between timestamp and C timestamp. One very important aspect of these new key segments, that it does change the way data processing when working with ISAM files. Now as never before, these key segments return data after a store, write, delete operation. The program needs to handle that. So for example, if you move data into working buffer before you write it to the file, that data now needs to be moved back from the working buffer, because these key values will have or may well have changed depending on the type of file operation. These values are stored in these segments that are not regular date values either. If you wish in your code to see the values in them, you must use the date from I8 function. The value returned is the alpha A20. It's the same format as the %DateTime function in the language. There is also a datetime to I8 function, which you can use to convert values to these strange date values, these I8 values. If you're looking to read a file based on a particular date, then you can use these functions to convert the values to and from. The toI8 function accepts a regular alpha 20. So now our IFSAM files are correctly defined. We have the right keys and the right segments. Yes, good one. One of the most powerful features added to Synergy in recent years is the ability to add I/O hook logic, or hook events to logic when actions in a file occur. Don't confuse these with triggers in a database. We don't have that capability. I/O hooks provide the ability to hook into your application code that is executed both before and after your program has performed some sort of I/O operation. You don't actually control when the code is executed. The runtime manages that, and this makes it very simple to implement. I've implemented a system using I/O hooks that provided the ability to lock records or monitor lock records in a file. So now you can run a utility that shows exactly who has a lock on which file, when, where. A very powerful capability, and it can save many hours of frustration at a customer site going, who's got the record locked? Because somebody's gone off to make a cup of tea or coffee or gone for lunch. If you'd like the code for the lock manager, complete with I/O hook class and the utility that allows you to monitor them, then just visit GitHub. Just search for DevPartner 2016 and all the code is up in that repository. So I'm not going to go through that again, obviously. But I am going to talk about how it actually works and how simple it is to implement. The hardest thing is writing the required code in the event handlers to do what you require. You write a class that basically defines a number of pre-named methods. For example, you're going to write a method for a before and after event of a store. When the code executes the store command, your application code, the runtime will call into your pre-store method and basically say, I'm about to store this record in the file. You can do anything then. Once the store operation completes, and remember that data may have changed depending on the timestamp keys you may have, the post method will be called, and again, whatever logic you want to do, you implement. One thing to note is that any errors will be passed through. So for example, if you have a post store event handler, and you encountered a duplicate key error, your event handler, your post store, will still get called, and you'll be passed the error. So you need to do and check, oh, do I actually want to do my function? One thing you can't do in an I/O hook handler is error processing. You cannot throw errors inside a handler. Using these methods allow you to record reads and read-s's that were in a file. You may want to do that so you can actually store the record that was read from the file once it's been read. When your application then goes to update a record or even delete a record, you can hook in logic to execute additional operations. Both of these will obviously remove locks from the file, so if you're recording lock monitoring, this is the place to do it. Once you have the class defined and written, you can plug it into your application. Ideally, if you have a single method or routine that opens your data files, this step is a breeze. Just change that once and life is good. If not, and there will be some, then I recommend you create one and then go through your application and use it. Simple. Create an instance of your I/O hook derived class and assign it to the open channel. You know me, always up for a plug about Symfony Framework. The file I/O class available in Symfony Framework can still be used with I/O hooks. You basically just pass a class containing your hook event handler methods when you create the file I/O instance, and I do the rest for you. I hook it all up. Job's done, as they say. All actions in the file that have been assigned to your I/O hook class will be invoked when those methods are processed by the runtime. So what can you use I/O hooks for? I mentioned earlier that I'd implemented a lock monitoring system, which again, DevPartner 2016, I showed it. Go get it, go see it. But during a recent engagement with a customer, we discussed the ability to enable real-time mirroring of data. Obviously, there's hardware options and configurations with RAID disks, etc. to do this. But what about a simple solution that ensured transactions to a file on a server were replicated to another server, maybe in a different part of the world. It will provide the ability to switch data servers at any time, or simply go, oh dear, I've had a real problem, get the data back, etc. Now, we've talked about replication many times at the conference, and I think it gets talked about this conference as well. But those sessions have always been about replicating data from your ISAM file into a database so you can go and do something with it, data mining. This is not that. This is mirroring your ISAM file on one system to an ISAM file on another system. Now, there are overheads. The client application is the one making the second access call to both servers. You may not then replicate every file, just the most important ones that ensure your business could continue if your production server suddenly went down. So how can we do this? Our first coding exercise is to create a class that extends the base IO hook class. The constructor will accept the channel the file was opened on and the actual file name, and we can use these to then determine the name of the replication file details. Call the base or parent constructor. The call structure here using IO_event_match.auto is telling the base class to determine, you go work out which methods I've provided you, I don't want to tell you. Using logicals, as we see here, we can determine the location of the replicating data server and the XF server port number, because that's how we're going to communicate with it. We determine the file name and open the replicated file on the server. In the post-store operation, we can test if the original store operation was a success, because we don't want to try and replicate errors. Your method will be called regardless, as I said, of the success of an operation. So you need to check that before you decide what you're going to do. If the data file has new key segment types, like the timestamp or creation timestamp, then yeah, the two files are not going to be identical, but the actual application data inside them is. We also need to handle when data is updated in a master file, so we need methods to handle write operations. We also need methods for when a record is deleted, so that we can replicate that delete on the mirrored file. Because we need to replicate updates and deletes in the mirrored file, we need to be able to read and lock records in the file. To do that, we'll write methods to handle read and read_s, so we can store the data away, so when we want to replicate on the remote server, we can reread and lock that mirrored file. And we better catch the file close and close off the mirrored file. So we've looked through the new key segments, which is all fine. We've seen IO hooks, and we can see where we can use these to not just replicate SQL data. SDBMS provides a few utilities to manage and optimize your files. I'm assuming you're all using these, but we're going to just quickly cover them anyway. ISLoad is a utility that lets you unload and load ISAM files. It's been around ever since ISAM was invented and can handle files with simple data. By simple data, I mean non-integer data, data without integer fields. But in place of ISLoad, you should really be using fconvert. The utility works much faster and handles integer data correctly. And remember the new key segments we talked about earlier, timestamps, etc., and the sequence, they're all integer data types now, so you need to be using fconvert. To unload from an ISAM file and reload to another ISAM file, you can specify an intermediate counted file, and this format ensures that any integer data you've got in your file will be handled correctly. You need to keep a check on your data files, just as you would with a database. Although rare, data corruption can occur in an ISAM file. Ooh, and I thought we were perfect. But, however, there are utilities to check and recover data corruption. Use them regularly in your SDBMS system tip-top condition. However, don't use ISM Verify. It's not the tool to use anymore. ISUtil offers a lot more utilities and recovery options and is much better to do recovery of files. Use the -v option around your standard backup processing every night, for example, to verify the file's integrity internally. If the file verification operation does show corruption, then use the -r option to recover it. Hopefully you're all doing the -v, hopefully you never have to do the -r. The IPAR utility simply creates a definition from the existing ISAM file that describes the full structure of the file, the key segments, the size, etc. You can use the definition file with fconvert to create new ISAM files or to convert other files types to ISAM. The newish utility, CTUtil, is available to manage change tracking facilities within your ISAM file. Now, change tracking allows you to monitor and track record changes to ISAM files that are being done by your application without you doing anything. Change tracking uses snapshots to record changes in files. Be those changes new records stored, existing records updated, or deleted. Each snapshot supersedes the previous one. Snapshots build on top of the previous one. Changes in one snapshot are recorded, and the state of the records in that file become the snapshot for the new snapshot at that point in time, or the base of that new snapshot. You can configure a file to track changes in snapshot at any time. It doesn't have to be a new empty file. So the first or base snapshot may actually contain records and has changes made that will then be recorded in that snapshot. Creating a new snapshot basically takes the state of that file at that point and makes that the base for the new snapshot. Changes to the data in the file will now only be recorded in the new snapshot. You can't actually touch the data in the previous one. From an application point of view, there are no changes whatsoever to your code. It doesn't know any difference whatsoever. Again, a new snapshot takes the state of the previous snapshot as its base state. Any changes from this point forward will be recorded in that current base state. Everything happens to the current base state. Using the select class, which we'll talk about next, you can retrieve records from any snapshot in a file. You can also roll back snapshots. The rollback process can be applied to one or more snapshots and takes the file, the records within it, back to a state before that last snapshot. Now obviously this can be quite dangerous because you may not want people to be able to, or your application even, to be able to roll back options. So there is an option where you can disable rollback capabilities in the file. You can still use select, but it disables the rollback. Now probably one of the most powerful new features added to Synergy in recent years is the select class. It gives you the ability to interrogate your ISAM files using queries syntax. And as you saw in Rural, they use it everywhere and all over the place. The syntax is clean, the coding is object-oriented, which makes it appeal to the younger, fresher developer. And the performance of your applications can be significantly improved, especially if you're accessing data over XF Server. Now, I did a complete session at last year's conference about the select class, and the videos are available on the conference website or the YouTube website. But here you can see the simplest syntax. We're just looping through all the records in a file using the select class, and the from identifies the file where the data is coming from. One of the really cool features of the select class is the ability to limit the amount of data. We call it a sparse select. To define the fields to be returned from the select, use the sparse record method on the select object. When you set up a sparse select, you tell the command to limit the data returned to the program. Again, a big performance boost across XF Server. The underlying record structure does not change. It still has the same defined fields. It's just only going to populate individual fields, not the whole record. This is probably one of the most efficient performance improvements you can make to your application if you're using ISAM and you're using XF Server Plus. It's as simple as that. But just be careful that your program's not accessing data that you have not requested. You don't get any sort of exceptions. It's just the data won't have anything in it. Of course, you can do more than just select data. You can apply filtering, as by specifying a where clause. You can also provide order by fields, so the data that comes back to your program is pre-filtered and pre-ordered as the program requires. This all eliminates the need then to bring all the records back, sort them, oh I don't want that one, I don't want that one. It's easy, it's one line of code. Last year, we introduced the ability to join files and return views of data from multiple files from a single line of code. The join capability is hugely powerful. The select syntax has been enhanced with the on class, which is cool, that allows you to connect one file to another. And then you use the join method to perform that operation. The results are no longer a record that come back, but a rows object. Again, we're all OO here. And you can iterate. Iterate just means go over, read through all the rows in a collection. Now, inner joins allow you to select records from both files or both sides of the join, as long as there's a match between the files on one side and on the other side. The left join returns all the records from the left-hand side and only matching records from the right-hand side based on the comparisons in the on. There's no real limit to the number of joins you can perform. The code just gets harder to read the more you do, I guess. And it can get confusing, but life is like that. You can see what the select class is doing after it's performed the operation by setting a couple of logicals, dbg select and dbg select underscore file. When you set these, you get a detailed log after the operation of what the select class did. And you can use that to fine-tune, force it to use this key because I know better than the select class. It does a good job, but it's not perfect. As well as the obvious enhancements to your application code and the performance improvements, if you're accessing data across XF Server, there are so many uses for the select class and the new join capabilities. Recent engagement with a customer involved using the select join capabilities. The customer's got an existing website and a lot of non-Synergy clients. They use a gateway and the Synergy XF ODBC driver to access data. We are looking at replacing the ODBC calls with Synergy.NET methods that use the select class and the join capabilities to access the data directly. As well as providing access to the data, we can then also provide access to run Synergy logic and still ensure data and application integrity. We can also customize the view of the data and have better control over how the data is presented to the client. Now, if you read the blogs we post, you'll know about the Synergy DBMS Manager. This utility allows you to run queries like SQL with the SQL syntax, as you can see at the top, and it returns the results, as you can see at the bottom. I'm not sure the image is great, but we're going to have a demo of it in a minute. It's very easy to do. You don't write any code to do this. You code generate some data objects from your repository structures and just plug it in. And the rest, as they say, is child's play. In addition to be able to select data, you can also manage data using this utility. The utility uses Symphony Harmony to parse the SQL-style commands and converts them into select calls, Synergy select calls. Synergy select calls allow you to perform updates and deletes as well as just selecting. To store records in the file, Symphony Harmony uses a regular store command. Now, although not directly related to ISAM files, and I'll show you an example of this later, the Symphony Harmony provides the concept of store procedures, where you can actually execute Synergy method on a local or remote server using SQL syntax, as you can here with the exec. So you can exec or execute, and you can test these store procedures through the SDBMS Manager. And again, I'll show you an example of that in a minute. The syntax of the store procedure is namespace.class.method. You can specify arguments that the method expects. In here, we're passing a string. As long as the simple .NET types, if you've got a method that accepts a data object, it's going to be a bit more difficult. As with all calls through Symphony Harmony, the response is always a data object or a collection of data objects, so we can display the results accordingly. This image is taken direct from not only the demo I will do after this, but from the post-conference workshop. Okay, just a couple of quick items then. From 10.3.3, we now check the client and the server versions when using XF Server. If the client is newer than the server, you will get a new error on the client. Prior to 10.3.3, although we didn't actually support this newer client to an older server, we didn't actually complain about it. Now we do. Ensure that you always upgrade your server first and then your client. There's also a new flag to control what happens when a record is deleted from a file. By default, when a record is deleted, we literally just set a flag that says, hey, I'm no longer here, you can't see me. But the data actually physically remains in the file on the disk until such time that another process actually overwrites it. Leaving data in the file could be considered a security risk, so this new flag ensures that the record, when deleted, is completely nulled out. This flag can't be set if you're using change tracking. Another new switch that allows you to control the maximum number of records that you can have in a file. Okay, not usually something you would want to impose on a file, but if you're deploying to a device like a phone, for example, where storage capabilities are limited, this option may be valid. And a similar switch to record the limits of a physical size in megabytes of a file. Again, this is to control storage on devices such as mobile phones. A quick highlight and overview of just some of the great features of Synergy DBMS and how you may use them in your applications. Okay, I'm going to bring up a virtual machine. The demo is based on the post-conference workshop. We've created a simple maintenance program. It's WPF. It's written using Symfony Framework and Symfony File I/O classes. Data is stored locally on the VM. I'm going to show you the code where we've added an I/O hook class that automatically replicates the data to a remote Microsoft Azure server running in the cloud using Symfony Harmony and Symfony Bridge. So, let's see. We have, obviously, Visual Studio running. I have the complete solution in here. In here, we've got the complete solution that we will create. We're going to write every line of code of all these projects tomorrow. And if you look at them, we've got a server project here, and we've got a file maintenance project here. These are the only two we're going to quickly fly through today. The server project has data objects in them, code generated, and we've extended one of the data objects with an I/O hook class. So, here is our constructor. And what we're doing here, this is the constructor that we will then pass to our file I/O handler to say, hey, when operations happen to a file, come and talk to me. This is how we connect to Symfony Bridge, okay, or Symfony Harmony, basically. And the bit you've got to remember is this line, symfonybridge.cloudapp.net 8081. That's a remote Microsoft Azure server somewhere in the cloud, somewhere in a different universe, on a different world, in the galaxy of life. We have certain operations that we're going to handle. So we've got a post store. If we get a post store, we're going to call it an internal method that just stores the record away and does an insert operation. Okay? We then have a read. I'll not go through these, but we have a post read that stores the record away. We have a post read S that stores the record away. We have a write operation, or post write, that again, check the error, store the record, perform an update operation. Because each one of these, we just want to replicate whatever's happened to the local ISAM file, we want the same thing to happen to our remote file on the other side of the world. Same with delete. That's where we're just storing the record. And here's the logic that we're now going to call. Now, this is where we're going to get into a bit of Symfony Harmony. So here's our insert command. So that one line of code is going to take this data object here, and using this Harmony command, looks very SQL-like, it's going to send the data to the remote Azure server and do the operation. It's going to insert it. Down here we've got the delete operation. Okay, there's the command that we're giving to Harmony, delete where barcode equals 1. If we didn't put the where clause on, we'd clear the entire file. You have been warned. The data it'll take up there is from the data object, and there's the positional parameter for that one. Okay, and very similar for update. There's the command, update vinyl details where barcode equals 1. That's the data object, and that again is the key value. So, I'm just going to run this and hope for the best. As I said, this is Richard's record store. Now, the code for this is all built using the Symfony example community project I talked about. Okay? This is exactly the same as what Gordon was showing yesterday. But I've extended a couple of the data objects because I've got images in there. So I've got now a catalogue of the records that I own at home. And this is basically what this is all about. If I sort this and go and look, I want to show you one of this album here. If you look at the information down here, that album cost me £299 for a round bit of black plastic with grooves on it. It's actually worth a lot more than that now. It's actually a special pressing of one of probably the best albums in the world. According to me, you may not agree, the Bruce Springsteen Rising album. Absolutely fabulous. So, what we need to do then is to see how our data is going to get replicated. So if I make changes in these, I need to see the data. So, I'm going to bring up the SDBMS manager, which we talked about in the slides. Now, notice the same information here. Here's my Symphony Bridge CloudNet.app and 8081. So this is going to talk to directly the same Azure server. I shall log in. And I'm going to do just a simple select barcode, artist, title, cost price from vinyl. So if I execute that, what that's doing is making up the connection, going to Azure, running the query, bringing back a collection of data objects. Now if we look down here, you can see hopefully there was 53 items selected. Okay? So how can I prove that I can now make modifications in here and you'll see them? Well, I'll tell you what, let's create a new album. Now, I could type in the information, the artist, etc., but I don't do that. So I've got my trusted, you should never go anywhere without your barcode scanner. So I'm going to scan that little beastie, because I quite like Elking, she's not bad. And then when I tab away from that, what that's done, it's gone to my code. We're going to write all this code tomorrow. It's gone to my code, and it's done a Google search. It's gone to Google. It's found the information based on the barcode. That's the only bit of information I put in. I scanned the barcode. It's found that the artist is Elking. The album is called Elking Love Stuff, and it costs $12 or £12, whatever the unit is. Okay? And it's also brought me back the album art. I've not typed that in. I've not gone and found it. It's done it all for me. Google searching, exactly like what Steve was saying yesterday. I've got my application using web services, i.e. a Google search API, to go and furnish information inside my application. So if I save that now, and I move back to here, remember this was 53, okay, no smoke and mirrors here. If I run the query again and cross my fingers, what we'll see down here is the value 54, okay? And to prove that that one was the actual album, I can say where bar underscore code equals, and the barcode, it should never be anywhere without your barcode reader. I can bring back Elking Love Stuff, 12 quid. I think that's a bit cheap myself, so I'm actually going to say it wasn't 12, it was £19.99. Okay? Now, as Gordon was showing, when you change data, the list disables, so you can't then go and change lots of things. And your button's down here, so you've got save and cancel. So if I do save there, and then I'll just do a requery, it should hopefully say 1999. Okay? So now I've got a completely mirrored database on my Azure server. If my laptop went down, I could recover my system, the data for my system at least. Okay? And you can do a few fancy things in here. You can select with a order by here. So I'm ordered by cost price descending. Okay? And if I query that one, I should get Bruce Springsteen right at the top, £299. Okay? And you can limit the stuff that comes back, so you actually only want to see the barcode, for example. You'll just get the barcodes and the cost price. One thing I did say was that you can now test your simple, admittedly simple at this point in time, stored procedures through this application. If I pick another album, I can scan it into here, and what that's going to do is go to my remote server, run the logic in my stored procedure. That's then going to Google to do a search, to then populate my data object, to serialize it over JSON, bring it back to my program, and display the results. Okay? And I can do the exact same thing in the program. So if I do new, when executing the method here, didn't store anything, it just told me, yes, it's available on the web. That's done exactly the same call. It's in one location. I can call it from my WPF, I can call it from my utility, and on the post-conference workshop, wouldn't it be really good if we could write an app for our little Android and iOS phone that maybe use the camera to barcode and scan, so when you're in the shop you could say, have I got this on vinyl? That's the demo. That's the SDBMS refresher. I hope it's been enlightening. I hope you've had a light bulb moment. Thank you very much for your time. I am finished.